All right, open up your book to section 8-6. We're on page 423 in your book. Title of this section is your double and half argument properties. So the objective here is first of all to prove that a product of sinusoids with equal periods is a sinusoid. So we've done that already. Sine times sine, sine times cosine, cosine times cosine, those all turn out to be sinusoids. The second part is to derive formulas for the cosine of 2a, sine of 2a, and tangent of 2a in terms of functions of a. That is your double argument properties. We've already talked about those. So it's the third part of the objective that we're going to cover today, which is to derive formulas for the cosine of 1/2 a, the sine of 1/2 a, and the tangent of 1/2 a in terms of functions of a. Those are your half argument properties. All right, so let's take a look at the property, and we'll go through and prove this just like we've done for the other properties here. So you have the sine of 1/2 a turns out to be equal to plus or minus the square root of 1/2 of the quantity 1 minus the cosine of a. All right, let's go through and prove this. We're actually going to use the product properties that we've already proven at the beginning of this section to help us prove these properties here. And so the product property that we had for sine times sine, is I had sine squared of x is equal to 1/2 minus 1/2 the cosine of 2x. And we're going to do a little variable substitution here. Maybe we'll note that over on the side here. We're going to let a equal 2x. So if you want to find out what x is equal to, that means that x is going to be equal to, if we divide by 2 or multiply by 1/2, x is going to be 1/2 a. And so that'll be our substitutions that we're going to make here to actually prove these properties here. So I've got the sine squared of, instead of x, I'm going to replace that with 1/2 a. You'll see that's where my half argument's coming from. And that is equal to 1/2 minus 1/2 the cosine of, instead of 2x, we're going to call that a. And now on the left side here, I've got the sine squared. So I want to replace sine squared with just sine. So we're going to take the square root of both sides. So I'll end up with the sine of 1/2 a is equal to, of course, when I take the square root, don't forget you get a plus or minus. That's going to show up over here. So it's plus or minus the square root of 1/2 minus 1/2 the cosine of a. And I guess in the last step there, if you want to factor out the 1/2, that's how they've written it. So I'll go ahead and write it that way. Plus or minus the square root of 1/2 this quantity, 1 minus the cosine of a. And there's our property. I want to point out one thing here, and I guess I could have pointed out from the beginning when we saw this property here. This plus or minus sign that you see out in front here, they refer to that as the ambiguous plus or minus. Ambiguous plus or minus sign, I guess I'll say, just to be specific. And the reason why we say it's the ambiguous plus or minus sign there is because we're not saying this is equal to both of those. You've got a little bit more work to do at the end when you're using this property to figure out, is this supposed to be a positive or a negative value? Remember, sine is a function. When we say sine of 1/2 a, the sine of 1/2 a has to give me a number. I don't get two numbers as a result of that. I only get one. It won't be both a positive and a negative number. That violates the rules of being a function. It wouldn't pass a vertical line test if that was the case. So it's the ambiguous plus or minus because we got to figure out which one of those two is the right one to pick. It's tricky there because of the fact that you're squaring this quantity in the previous step right here. You can see that you're squaring that. And so to solve for that, you end up taking the square root. But the problem there is that when you're squaring that quantity, you could have a negative number or a positive number that you're squaring, and you get the same result. You always get a positive result there. So that's what we're looking for at the very end, is to figure out which one of those two it is. All right, we'll talk about that a little bit more at the end here. All right, let's look at the second property. The second property, the half argument property for cosine. The cosine of 1/2 of a is equal to plus or minus, there's that ambiguous plus or minus sign in there again, plus or minus 1/2, the square root of 1/2 of 1 plus the cosine of a. And again, the way that we're going to prove this is using the product properties, or it was actually the square of cosines to do this again, from the first part of this section. So our property was this: if we have the cosine squared of x, we said that was equal to 1/2 plus 1/2 the cosine of 2x. All right, so we're going to do the same substitution that we saw on the previous slide there, or the previous problem here. I'll write it over here just to remind ourselves of that. We're going to let a equal 2x, and so that means that x is going to be 1/2 of a. So those will be our substitutions that we make into this. So we've got the cosine squared, but we're going to replace x with what we said it was equal to, 1/2 of a. And we've got the cosine of 2x, but again, we're going to replace that with what we said 2x was equal to, which is just a. All right, now let's go through the same process there that we saw above. I want to find out what the cosine of 1/2 a is equal to, not the cosine squared. So I got to get rid of that squared. We'll take the square root of both sides to do that. So we got the cosine of 1/2 a. Again, remember when you do that, you actually get a plus or minus that shows up here. And it's 1/2 plus the 1/2 the cosine of a. And the last step there, if you want to factor out the 1/2 like they have written up above, we can do that. So it's plus or minus the square root of 1/2 of the quantity 1 plus the cosine of a. And again, I'll point out to you that we end up with this plus or minus. That's that same ambiguous plus or minus because of this squaring that we are doing here. To get rid of that square, we got to take the square root, and that introduces two possible solutions. Again, the key is that it's two possible solutions. We're not saying both of those are solutions. One or the other will be. Cosine of 1/2 a will give us one number. And we got to figure out at the end, is that number supposed to be positive or negative, to help us figure that out. We'll talk again about that at the very end here of this slide here when we get through the other half argument properties. Oops. So the last set of half argument properties here is for tangent. Tangent of 1/2 a. It turns out there's three different ways you could write this. The last two ways are a really nice way to write it, but those are actually quite a few steps to get to that point. And actually, that's a Pythagorean, or sorry, that's not a trig identity we've proven. If you go back and look at some of the trig identities we've proven, if you take 1 minus the cosine of a, this last part here, 1 minus the cosine of a divided by the sine of a, and set it equal to the sine of a over 1 plus cosine of a. We've actually proven that previously that those two are equal to each other. So once you get to one of those two, it's easy to prove the other one. But it is tough to go from this square root thing to what you see there. So I'm going to skip over proving that you get to one of those two at the very end, but I'm going to prove that you can get the first one that you see here. And we're just going to use our quotient property actually to do this. So I have the tangent of 1/2 of a. So we're going to approach this a little bit different from what we just did in the previous two proofs there. In the previous proofs, we had what sine squared and cosine squared was equal to. We already had done that work. We have not proven what tangent squared is equal to. If we had, we would probably use that at this point. But instead, we're going to rewrite tangent as a quotient. Tangent, I know, is equal to the sine of 1/2 a over the cosine of 1/2 a. That's your quotient property for a tangent. And then let's replace the sine and cosine of 1/2 a with their half argument properties that we just proved up above. Sine of 1/2 a is plus or minus the square root of 1/2 of 1 minus the cosine of a. And cosine is plus or minus the square root of 1/2 of 1 plus the cosine of A. And we can simplify this. First of all, the plus or minus that you see there, you can think about kind of combining those with the numerator and denominator. You know, if they're both positive, then a positive or positive, that's positive. If they're both negative, then that still turns out to be positive. If they're opposite signs, then you get the negative part of this. So you still will have a plus or minus out in front of this thing. And then if you have the square root divided by a square root, we have a property that says you can write that as the square root of this whole thing. 1/2 of 1 minus the cosine of A divided by 1/2 of 1 plus the sine of A. Oops, not sine. Still cosine. Don't change your trig function there. But it is addition. And then actually you have a 1/2 and a 1/2 there that you can cancel out. Those are common factors. So that actually is that property there. If I just scroll back up a bit, you can see that that's the property that we started out with there. Plus or minus the square root of 1 minus the cosine of A over 1 plus the cosine of A. Again, it takes quite a few more steps here using conjugates and Pythagorean properties in order to get what you see there in the last two. So I'm going to skip over showing that, but certainly that that is a nice way to write it in the last two forms there. All right, one last thing here. I've mentioned this several times now, and I guess that maybe I should point this out again, that you have this plus or minus out front, and that's, again, an ambiguous plus or minus. Tangent of some quantity is going to give us one value. Tangent's a function. I only get one output from it. I have to figure out which one of those two is the right one, whether it's positive or negative. So the way to do that is to go back to our little acronym that we've used all along here to figure out whether your trig function is positive or negative, and in which quadrant that's in. That was that acronym all students take calculus. A means that all of your trig functions are positive there. S means only sine and it's reciprocal. T is for tangent, C is for cosine there. Tells you what quadrants your trig functions are positive in. So this says that you can find the right value here. The ambiguous plus or minus sign is determined by the quadrant in which 1/2 A terminates. So you have to think about where 1/2 A is at, what quadrant are we in, and then use this to help us figure out, well, are we positive or negative in that quadrant. All right, so let's try a couple of examples here. Actually, it's one example, but it's got multiple parts to it. Take a look at example 4 here. They give us the cosine of A is equal to 15 over 17. And it says, and A is in the open interval from 270 to 360. So A is an element of the set from 270 to 360. I guess another way to write that would be to say that 270 is, oops, 270. 270 is less than A, which is less than 360 would be another way of writing that same thing. That will, the second way will actually be a little bit more useful to us here when we get to the later parts in this problem. But for part A, it says find the exact value of cosine of 1/2 A. So for part A, I guess it's in the first part. I needed to know that information here. Cosine of 1/2 of A. All right, so cosine of 1/2 of A. Use your half argument property to answer this question. This is going to be equal to plus or minus the square root of 1/2 of 1 plus the cosine of A. Again, the key here is that they told me what the cosine of A is equal to. They did not tell me what A was equal to. They told me what the cosine of A is equal to. I can replace cosine of A with 15 over 17. I'm not going to replace just A with 15 over 17, but it's the cosine of A with 15 over 17. Make sure you're doing the correct substitution there. So again, cosine of A, I'm replacing all of that with 15 over 17. I'm going to deal with the plus or minus at the very end. Let's first focus on the on the result of this calculation here. Let's simplify this. Get a common denominator, 1 plus 15 over 17. I guess we can write that as 1/2 of 17 over 17. That's 1 plus 15 over 17. And then when I add that together, I've got 1/2 of 15 and 17 is 32 divided by 17. And when I simplify that, the 2 and the 32, that'll leave you with 16 in the numerator, it looks like. So we actually have plus or minus the square root of 16 over 17. And you can leave it just like that. Or if you want to actually simplify this further, the square root of 16 in the numerator is actually 4. So you could actually write this as plus or minus 4 over the square root of 17 if you want to go a little bit further with that. All right. Now, the last part of this is to figure out this ambiguous plus or minus. All right, I'm doing it at the very end. There's nothing that says we have to wait till the end, but we're waiting till here to figure out what that's equal to. So the way to figure that out is to go back and look at A that they told us. They have to give me a restriction on A in order for me to come up with what this is equal to. Let me just move this second way that I wrote this down. I'll just move this down over here. They told us that A is between 270 and 360. I'll just put it at the top here. And so with that, I can now figure out where exactly 1/2 A is at. If I just multiply through by 1/2, that'll tell me something about 1/2 A. So half of 270 is 135. Half of A is 1/2 A. And half of 360 is 180. So if A is between 270 and 360, I can then figure out what does that mean about 1/2 A. It's got to be between 135 and 180. So now what I want to do is think about, okay, what quadrant am I in if I'm talking about an angle, 1/2 A, that's between 135 and 180? Well, here's 0, here's 90, and here's 180. And 135 actually would be halfway through this, right? 135 is actually right here, halfway through the second quadrant. So we're talking about an angle then, that when I measure it, 1/2 A lands somewhere in here. I'm not sure exactly where it lands, but 1/2 A is somewhere between 135 and 180. Okay, so it could be anywhere in between there. The key is, though, 1/2 A is got to be in the second quadrant. We're in quadrant 2. And so in quadrant 2, again, think of your acronym here. All students take calculus. This is the quadrant where only sign is positive. So that means I'm going to expect that my cosine of 1/2 A, has got to be a negative value. So at the very end, I can say that this has got to be equal to a negative 4 over the square root of 17. By the way, that analysis that we just did there for figuring out the plus or minus, you don't have to wait to the end. You could have done that in the very first step and figured out that it's going to be a negative value that you want, and then you don't have to keep writing the plus or minus down every time. You could figure out that it's the negative number initially. But that's how we determine whether we have a plus or the minus. Okay. Part B. Part B says to find the cosine of 2A. Ties into what we did in the first half of this section. Cosine of 2A. And again, think there's 3 different ways you can write cosine of 2A, 3 different double argument properties for cosine. I only know something about the cosine of A, so pick the one of the 3 that involves just that. So that's 2 cosine squared of A minus 1. In fact, I'm going to rewrite this as the 2 times cosine of that quantity squared minus 1. And again, I want to make sure it's clear here that I'm not replacing A with 15 over 17. It says that the cosine of A is 15 over 17. So my substitution that I'm going to make here in just a second is going to replace all of this. I'm not replacing just A. That's a very common mistake, is why I'm kind of trying to point that out here. I'm replacing cosine of A with what it's equal to. So it's 2 times cosine of A, we said was 15 over 17. squared minus 1. So we're replacing cosine of A with what it's equal to of 15 over 17. And let's grab our calculator to evaluate that or square that thing out there. That will probably help us out here. I'm just going to grab that and punch that into my calculator. 15 squared is going to give me 225. And 17 squared is going to be 289. 289. So I'm squaring those out there, and then we'll simplify this now. Now that I got these as fractions, I can simplify. Doubling that fraction just doubles the numerator, so you end up with 450 over 289. And I probably want to get a common denominator, so let's write that as 289 over 289 for what 1 is equal to. And now we can subtract. You might want to grab your calculator and punch that in. 289 from 450 gives us what? 161 over 289. And there's our final answer, and you'll leave it in that form there. Okay, leave it as a fraction just like that. If it does simplify, you can certainly simplify it, but that's as far as we want to go. Now for part C, it says verify your answers numerically by calculating the values of 2a and 1/2a, and then finding the value, finding the cosines. All right, so this goes back to solving a problem that we've solved many times now. We were initially told that the cosine of a is equal to 15 over 17. All right, and they also told us that we're looking for the solution, or I should say a is between 270 and 360. Okay, that's the solution that we're talking about, that we're looking for here. That's what A is. A is somewhere in the fourth quadrant is where that's at, if we're sketching that in standard position. So to solve this, we say A is equal to the arc cosine of 15 over 17, where that's plus or minus the cosine inverse of 15 over 17 plus 360n. Again, we've solved a problem like this many times now. We just got to find out what's the right solution. There's lots of solutions here. We want the one that's between 270 and 360. So what value of A should we be picking here? Well, sketch your graph of cosine. Cosine does something like this, from 0 to 360. And in particular, I'm looking for the solution that's between 270 and 360. So that's the solution that should have done a little better sketch here. This is 180. So here's where 270 is, where I cross the x-axis. So we're looking for the solution right at the very end there. And again, we're setting this equal to a value of 15 over 17. So that's somewhere about here, we'll say, is 15 over 17. So we're looking for that solution right there. So to get that solution, our phase displacement there was 0. So A equals 0 is where n is going to be equal to 0. So this is n equals 0. N is going to be 1 here, and you want to use this solution here, so that's going to be the negative cosine inverse solution. So it looks like the answer that we're looking for here, for A, is actually equal to a negative cosine inverse of 15 over 17 plus 360 times 1, and it's going to be 1. That's the answer that we have here. That's the number we need for A. So let's grab our calculator. We'll find out what half A is and 2A, and we'll see if, in fact, the cosine of those quantities give us the result we're looking for. So grab your calculator. All right, so on our calculator here, again, we're doing this in degree mode, so make sure that's where you're at on your calculator. Mine's in radian mode, so I got to switch that over. All right, so let's find out what the negative cosine inverse of 15 over 17 and then plus the 360 gives us. And I'm going to go ahead and store that into A on my calculator. That's our value for A. And again, they told us A was between 270 and 360, and there we go. 331, it falls in that interval. So that's the value of A that we're working with. And now let's compare that to the calculations that we came up with. Let's take the cosine of 1/2 of A. If I take the cosine of 1/2 A, I get this decimal amount. First of all, notice it's negative. That was that ambiguous plus or minus sign that we had to figure out. And we figured out it was supposed to be negative. Yes, that's what we should have. And now let's compare that to the calculation that we came up with. We said it was a negative 4 over the square root of 17. And yeah, that's the same thing. That one checks out. And then the one that we just calculated was the cosine of 2a. So let's calculate the cosine of 2a. And we get a positive 0.557. Now we simplified that all the way down and found out that that was equal to 160. It was 161 divided by the 289 is what we simplified that to. So compare those two, and there we go. That all checks out. In fact, I'll grab a picture of that. And we'll paste that in there. Everything checks out there in terms of the cosine of 1/2a and the cosine of 2a turn out to be the exact same quantities that we came up with. All right, that there is the end of this section 8-6.